Table 2, can you tell me which one doesn't belong to you and why?
C is the only one that is.
Okay, this was the only one that's dotted. Anyone at table 2 pick something different?
I picked the,
And why'd you say that one doesn't belong?
the only ones that the line intercepted into.
Okay, so let's verify if that's right. On all the others, the y-intercept is 2. And in this one, it's like 3.5-ish. So that is a good observation. Any other ones, table 2, you want to share? Okay, table 3. Even though you might not have picked A as not belonging, can you give me a reason it doesn't belong? There's no other straight line? Okay, so it's the only horizontal line. Does anyone have like another reason A doesn't belong? Anyone? Okay, so only horizontal line / flat. What happens to it that makes it flat? So it's the only one with no slope. That's why it's horizontal and flat. Or really the slope, it's not that there's no slope, but the slope equals what? 0. The 0, I guess, is technically still a slope. It just gives no rise. All right. Anyone else want to give me a reason A doesn't belong? Okay. Then table 4, even though you might not have picked B as not belonging, can you give me a reason it doesn't belong?
It's a straight line
There's no other straight lines on it?
of the straight line.
Okay, straight line that's going up. Straight line that has a positive slope. Can anyone give me any other reasons it doesn't belong? Are you sure there's no other ones that are? A is also linear. But anyone else? I think that's good. All right, you use a lot of your vocab, so that's really what we search for in these which ones don't belong. One thing I would add is that we call dotted graphs discrete. That's like the more mathy term for it, and the rest are continuous. So on C, the dots mean that it can't be the numbers in between the dots for the X. And it can't be the numbers in between the dots for the Y. The rest is continuous, so you could have like decimals both ways. Everything in between. Okay, so good. That brings us to our goal for today. Let me briefly share that with you. You can all go back. So the goal for lesson 7 is to look at how to maximize revenue. So this is part 3 of our series of using quadratic functions to describe situations. By the end of the lesson, you should be able to choose a domain that makes sense in a revenue situation. Domain refers to all the what? The what? Not the y. All the x's in a function. So do you guys even know like what revenue is? Nothing. Okay. Well, what is usually on the x-axis? Can you tell me that? Time. And revenue would be money related, almost like a profit. So revenue would be probably in dollars. So if we're trying to maximize revenue, trying to maximize our profits, this learning target says we want to choose a domain that makes sense in a revenue situation. So it could be like, I don't know, if we're looking over 10 years, 0 to 10 years and everything in between. If we're talking about over a century, we could go from 0 to 100 years. It just depends on the situation. But you will determine what definitely it cannot be and things like that. So we'll talk about that later. You have to be able to model revenue with quadratic functions in graphs and relate the vertex of a graph and the zeros of a function to a revenue situation. I'm recording right now. It'll be linked in the slides for later. Puzzle piece is lesson 7. And you can expect your next quiz to be Wednesday next week over lessons 3 to 9. On quizzes, you can use your notes. On tests, you normally cannot. So I never worry so much about quizzes. They're just like little checkpoints. But you should use that data from the quiz to see, like, should I come in for tutoring? Should I be on Wednesday to ask for help? I did make the quiz viewable to you so that you could see how you did, see where you're struggling. So they're just little checkpoints. You could always do corrections on them for half credit back, or consider coming to tutoring to take them. But also the little checkpoints are your practices, so make sure that you're doing those and asking questions on those if you need help. Moving forward though, here's the first like real world situation helps me on learning targets. A company that sells movies online is deciding how much to charge customers to download a new movie. Based on data from previous sales, the company predicts that if they charge, I'm assuming that should have been a variable in between there, that if they charge blank dollars for each download, then the number of downloads in thousands is 18 minus X. You're gonna complete the table to show the predicted number of downloads at each listed price, then find the revenue at each listed price. The first row has been completed for you. So that'll be your first task, is complete the table. It gave you some expressions like the part about where it predicts. So this column is our prediction, it looks like, is going to be 18 minus X. So this would be our X, because 18 minus 3 is what? 15. And then think about what they're doing to get to 45,000 of dollars in revenue. What would they be doing to get to 45? Multiplying 15 by 3. Okay, so using that row that's completed for you, fill in the rest, and this little expression that was given to you as well. Use that for this column. Table 5. When X is 5, what's my number of downloads? What did you Okay, sorry, I thought you said. Yes, because it's 18 minus X, this column. If you compare the first example, then yes, it is 13. Table 6, what about when X is 10? What's my number of downloads? 8. Table 1, when X is 12, what's my number of downloads? 6. Table 2, when X is 15, what's my number of downloads? Table 3, when X is 18, what's my number of downloads? It is 0. So you're plugging in the X into this expression. 18 minus 18 is 0. Now, table 4, what's going to be my expression that works for this row? If my input is X, what's going to be my expression? Well, Well, think about it, every single time we were doing this, we were doing 18 minus whatever x is. If my input is just x, then it's gonna be 18 minus. Yep, and that's it. I know the expressions are always the ones that confuse everyone the most, you can do it when it's all numbers. Now you're just like making a rule for it. That no matter what I plug in, I'm still getting the right answer. That works for this table. Okay, now remember the rule for how we get this last column. If this is my revenue, when the price is $3 per download and I had 15 downloads, I would have to do what with those again? Multiply them. That's how you calculate like how much you made. So then table 5, we're gonna rotate whoever's the last, like one to the left. So table 5, what's my revenue when it's $5 per download? 65 sounds right. Feel free to check that math. Those of you with calculators. All right, table 6, what about when the price is $10 per download? Table 1, what about when the price is $12 per download? Table 2, when the price is $15 per download? Table 3, when the price is $18 per download. Now that one's kind of an odd one, but no one's downloading it, so you won't make any money. So I guess that doesn't make sense. All right, now table 4 again, you have the harder one. What expression could I write to represent my revenue? Think about all the math we did to get like from these numbers to this. What did we do each time? So then all I have to do is take these expressions from these columns and multiply them. So everyone, you guys should have gotten, you could have written it like this. Or you could also even simplify it to look more like our quadratics. When you have numbers in this setup, what do you usually do with the outside number? You can also distribute it, and I'll do it down here so it doesn't mess up my cooking table. But what's 18 times x? What's x times negative x? Definitely gonna be negative, but negative what? Not 2x. Not just x. Not 0. Think of your exponent rules. Add x to the first times x to the first. That's x squared. And now it looks a bit more like our quadratic function, by the way. But this is like probably more so what you put on your paper. We did the first column times the second column. And you can't just do x times 18 minus x. It has to be times the difference of these two. You would have to technically do that first. That's what you did in the other ones, right? Okay, the order of operations. You can't just write it however you want. It has to be times the difference of them. So good. Now for the next part, you're gonna see is the relationship between the price of the movie and the revenue quadratic. Well, if we can write this expression like this, would you say that is quadratic? What makes it quadratic? How do you know it's quadratic from this expression? So it's because of the x squared. If you have an x squared in it and nothing higher, like not x cubed or x to the fourth, nothing like that, then it is quadratic. Next, you are going to plot the points that represent the revenue as a function of the price of one download. So the prices are here, that's gonna be your X. The revenue is this column. So the way that you're kind of graphing these, like you'll plot X and then its corresponding R. So I'll plot 345, I'll plot 565 and all the rest. So go ahead and make that on that coordinate plane that's provided to you. Then you're gonna answer, at what price would you recommend the company charge for a new lead? This is just like something that's on your constructive response, by the way. Three columns, it did tell you you're graphing the points that represent revenue as a function of the price for the download. So like these columns, is what you should plot. So like 345, 565, 1080, right here, and we scroll so we see on the back. But 1080, 1272, 1545, and 18 of the euro. Does this look quadratic to you? Yes, and we already established it should be quadratic because it has an X squared in it. It is U-shaped. Where would be like the maximum revenue? For the points that we plotted, the best point is when the price is $10. Now, we only plotted like intervals that it gave us. So if this was the question on the test, like what is the best price to sell your stuff at to make the most net revenue? Then what I would actually say is graph the expression, which we got from doing X times 18 minus X. And then when you look at the graph, you can tell exactly at what price is best. So if you were just estimating, around 10 would probably be a good estimate. But if you have graphing technology, which you do on all your tests, you could evaluate it by looking for your maximum. Where's my maximum? Like the very top of the sheet. You guys know it's super user friendly, and even once you click on it, it gives you two values. If I'm asking at what price should I make the movie or whatever, would you tell me 9 or 81? 9. To also be able to interpret what each one was representing. The X's were the price. And the Y's are my revenue. So it goes X, R, the $9 price point would be the best. And it wasn't one of our X's, but that's pretty close to 10, so you guys did estimate what. So the price that you would recommend would be 9, as it gives the most revenue. Okay, and the revenue itself is 81, and that's in thousands of dollars, so. Now, a bit of vocab that you would have learned from lesson 6, which obviously you guys are doing lesson 6 tomorrow. Do you guys know what that very top of the peak is called? In math? You're able to determine it in the context of the real world situation, so that's good. But if you look to your learning targets, one of the goals was to relate the vertex to a real world situation. And the vertex is the turning point of your graph. Okay, so you could point to it. Vertex is the turning point of a graph. So if our graphs are U-shaped and it's only this or this, then you either have a minimum, if it looks like that, or maximum. And since most of our real world situations are in this shape, it's most likely going to be maximum. Okay, questions on that? The other part of the learning target mentioned the zeros, which you would have learned that formally in lesson 6. Anyone know what zeros are? I'd be really surprised if you did. Another word for zeros? Okay. X-intercepts. So I imagine that's going to be my next part. Zeros are another word for x-intercepts, and if we're relating it to the real world situation, remember x's was the price per download and R was the revenue. So the question on the test, they can't right there when I say things like that. If the question on the test said at what price point would they make the least revenue, it would make the least revenue when the revenue is 0. So when the price is 0, they make no money. And when the price is $18, they make no money. So there's 2 zeros, 2 x-intercepts. That's what you would interpret them as in this situation. Okay, so questions on that? All right, really good activity. Well, just one more to do now, and it's relating all of those together, all of those vocabulary words together. Domain, vertex, and zeros. So in the previous activity, we saw a function representing the revenue in thousands of dollars from selling new movies at X dollars. If we graph the equation with graphing technology, it would produce a graph like this. And the reason it might not look exactly like the one we graphed is because you might want to adjust the window. Mine is adjusted differently, but it's still the same. It has a vertex at the same spot. It has zeros at the same spot. All right, but here it is on your paper graph for you. You now have 4 sets of descriptions and equations that represent some familiar quadratic functions. For each function, you're going to describe the domain that would be appropriate. Domain refers to all the what in a function. So you're going to determine all the x's that would be appropriate for the situation. And identify the vertex. Describe what it means in the situation. And identify or estimate the zeros. What are zeros again? The x-intercepts. That for some reason is like a really hard vocab word for students to like remember. Zeros just means x-intercepts. Vertex is your turning point of the graph. That will usually reveal your maximum or your minimum. So the descriptions you have and the pictures are on your paper. You are going to identify the domain, vertex, and zeros for each of them. Any questions? Yes. All right, then I'll leave you to it. With your groups, be able to identify domain, vertex, and zeros for each of those situations. And it says 4 sets, but it looks like there's really just 3. Okay, I've decided to help you out. Let's at least label this graph. And I know we did it on the Desmos, but you should still probably label it on this one because this is in your notes. What would my vertex be? That's 9? 981. So your vertex is always like the turning point, point meaning like it should be the XY. So this is my vertex. The maximum is really just the Y value, the 81. So you could see like when it reaches the maximum, it reaches it at 9. So yes. What are my zeros for this one? Well, 18 is one of them. So 0 is the other one. Because remember, zeros are your x-intercepts. That's when your y is 0. So these here in black are your zeros. The last thing it wanted you to figure out is a reasonable domain. Remember, domain refers to all the what? So see where the x's like start and end. Where do they start? For the line that's graphed. So I know these go in the negatives, but could I have a negative price? So we're gonna negate all the negative x's. So where should my x's start? 0. Where should they end? 18, since it does end at 18 exactly, you could say that. If it was like, I don't know, 18.5 or something, maybe you just want to round up to like 19 or something. But be able to, if you have options, identify what's the most reasonable. And can it be everything in between? Can the price be like a decimal? So in that case, you could even be more specific and say that your domain is all real numbers from 0 to 18. All real numbers contains decimals, fractions, negatives as well, but if I say from 0 to 18, there's no negatives from 0 to 18. So that is like a big test thing to do. Good, make sense? I think today we've done like 4 or 5 questions that would be on the test. It's a really important lesson. So using this as a model, for the next 3, be able to identify your vertex, your zeros, and a reasonable domain. So table 4, what's my vertex of number 1? Your vertex should always be like a pair of numbers. 6, 40. So this one, I would actually probably, because it's hard to estimate, I get it. It does give you the expression for all of them. But I do think that the y is just a little bit under 40. So let me pull up my Desmos and we can see what it is exactly. So we have x times 25 minus 2x over 2. All right, everyone see how I just copied it exactly? And now I can click on it. My vertex is approximately 640, but it is exactly 6.25, comma, like 39.06. That's it exactly. This is more of an estimate. Questions on that? Okay, so that's vertex. Table, who did I just ask, by the way? Table 4. So table 5, what are my zeros of this first one? Maybe that makes it a little bit better. Sorry, it's kind of blurry. Okay, definitely looks like it's going through the origin. Is there only one x-intercept? So then where does this one look like it's at approximately? What's in the middle of 10 and 15? 12.5. Because you know, it's like a span of 5 numbers, so right in the half, 2.5. But yeah, so my zeros are 0 and 12.5. If we write them as coordinates, they look like this. Their x-intercepts are when the y is 0. Table 6, can you tell me a reasonable domain? And they can't be right because we already spoke. 0 to 12.5. Class, would you agree with that? Is there a way to be more specific? How would it be on the test if it wants to include like all the decimals in between? So all real numbers from 0 to 12.5. I mean, I would know what you mean, but just be able to recognize them. Starting to make more sense? Okay, so then table 1 with my vertex will be number 3 because it's like right next to it. So what's the vertex of this one? Table 1. Can you tell me definition of vertex? Like Grace, help her out. What's my vertex for number 3? 0, 0. So your vertex is always going to be just one coordinate for our quadratics. It's the turning point of the graph. This one looks easier to see. I do agree it's probably 0, 0, even if I were to type it in. 16x squared. Because I think if I put a t, it might not read it. And yeah, it's at 0, 0 for that one. Good. Table 2, what are my zeros for number 3? It would just be 0, 0. I only have 1 0. 1 x-intercept, and it's at 0, 0. That's what it looks like when there's just 1 x-intercept. That's when the vertex is on the x-axis itself. There can also be no zeros. We'll see what that looks like in a second. Table 3. What's a reasonable domain for number 3? Can you tell me what the domain refers to, table 3? Well, now I've changed the question. So when it's domain, it's referring to all the what in a function? Domain refers to all the what in a function. We talked about it earlier. All right, class helping out, domain refers to all the what? All the x's. So look at my x-axis. And granted, we can really talk about like the x's that are on the line. But for this one, when we were talking about area of a rectangle, could you have negative x's, class? So that's why we didn't include the negative values, even though the graph extends to the negative for the x's. in this one, we're talking about the distance in feet that an object has fallen after being dropped. So could I have, and just stay with your I'm asking, could I have a negative distance? Or a negative second, when we're talking about domain, we're talking about second. So then it should be all positive numbers. Is there any restriction on the distance that is good for travel? Does it say like it stops at, I don't know, 100 feet or something like that? Where does it say that? So then there's no restriction. All right, there's no upper limit, but we know it can't be negative because that doesn't really make sense. I can't have a negative time frame for this. Domain is all the x's, so we're talking about the time possibility. Make sense? Okay, so then table 4, back to you, except this time I won't ask you about the vertex. This time I'll ask you about the zeros. What are the zeros for number 2? Yeah. Sorry, what's the answer? What are the zeros?
0.
Oh, okay. Is that an x-intercept? There is no x-intercept, so there are none. There are no zeros. So zeros, there is none. The 0, 4 might be a y-intercept, but not an x-intercept. Zeros have to be x-intercepts. Make sense? Any questions? And having your 0 be 0 is different than having it be, there's no zeros. Okay? So keep that in mind too. Table 5, what about the vertex? What is my vertex? Tell me the definition of the vertex. Okay, when you guys don't answer, I have to change the question. I have to now make it easier for me to do that. So what's the definition of vertex, table 5? Well, that's what you guys have. Get it together and figure it out. This is now the 4th example we're doing today of vertex. So the fact that we can't even tell me what a vertex is after now this being our 4th example, it's pretty rough. I don't know how else to do it. So figure it out, look back at your notes, have an answer. You only have one group ahead of you. So then table 6, what's going to be my reasonable domain for this situation? We're talking about the number of squares as a function of the step number. Well, just think about it. Domain refers to all the what in a function? And if we're talking about step number, which is what our x-axis is there a restriction on what steps we could have? So step number, like step 1, step 2, step 3. Could I have any negative steps? Could I have any fractions of steps? So how would you describe what my x's can be? You could start at 0. I mean, I don't think there's, we can start at 0 because I know like that would usually be where it starts. I guess 0 to what? Is there an upper limit on the steps? Does it say that we have to stop at like step 20 or something like that? So there's no upper limit. So it's like 0 to infinity. I'll rewrite this in a second, in a way that I think it would be displayed on the test. But you're saying that it can be 0 to infinity, can it be decimals? Can I have like step 2.5? So no decimals. So you would say all whole numbers. Or you could even say all integers, because that would also not include decimals. And you could say from 0 to infinity. Positive infinity, not negative infinity. I'll just put infinity because I feel like people will write that and then they won't know what that is. Okay, second on that. All right, then we're back to you, table 5. Which should I vertex of this? Okay, I might need to actually graph it to see if that's at 10 exactly, so give me a second to do that. But can you tell me what vertex means now? The turning point of the graph. So that like where it starts going from decreasing to increasing, that's what we mean. Let me erase these other ones that are there. So here's my turning point of the graph. It says that my turning point is 0, 4. Not 10. But if you're just going based off of this graph that's given to you, it is kind of hard to see, so I'll give you that. But vertex is your turning point of the graph. So questions, comments, concerns? All right, so we have a bit more time to do your practice, but there are some delays figuring it out, but hopefully we're all there. Hopefully we can all identify vertex, reasonable domain, 0, and if not, then you're really that. The practice is 6.7 that goes with this lesson. You can probably knock out a problem or 2 right now. Otherwise, it's 1. Second. Okay.